Go.
Hello and welcome to this second discussion on dexamethasone with the molecular formula C22H29FO5. This discussion will be focused on more of an advanced structural analysis. So let's get started. So we're going to pick 3 carbon atoms and 3 heteroatoms to discuss their hybridization, their electron arrangement, molecular geometry, and their bond angles. So the first one I'm going to focus on is this carbon atom here. We see that this carbon atom has a bond to this carbon down here, and it also has a bond to 3 H's around it. That tells us that we have 4 electron groups, and if you remember, 4 electron groups means we're going to have sp3 hybridization. So I'm going to write that here. The next carbon atom we're going to focus on is up here. This carbon atom, like the previous one, has 4 electron groups because we have a carbon-to-carbon bond here, and we have a carbon attached to the 3 hydrogens around it. So this carbon has 4 electron groups around it as well, so it will also undergo sp3 hybridization. And finally, this carbon down here has 4 electron groups around it because we have a carbon-to-carbon bond here, and this carbon is attached to the 3 hydrogen atoms around it. So as a result of this having 4 electron groups, we are also going to have sp3 hybridization occurring here. Now, I want to take a second to delve into the molecular geometry and electron arrangement and the bond angles of this carbon a little more. So, as we said before, this carbon has 4 electron groups because we have a carbon-to-carbon bond here, and carbon is bonded to the 3 hydrogens around it. We also have, this carbon also has the 4 attached atoms to it. So since it has 4 attached atoms and 4 electron groups and no lone pairs, we have a tetrahedral electron arrangement, and we also have tetrahedral molecular geometry. We'll write that here. As a result, the bond angles for this carbon will be about 109.5 degrees. So, now on to our heteroatoms. The first heteroatom I'm going to focus on is the O in this alcohol up here. So this oxygen has 2 bonds, one to the carbon here and one to the hydrogen here. It also has 2 lone pairs around it there to fulfill its octet. So we see that this oxygen has 4 electron groups. So we'll write it up here that it undergoes sp3 hybridization because it has 4 electron groups. The next heteroatom we'll focus on is actually this fluorine down here. We haven't talked about this atom yet, but I would venture to say that since this fluorine makes 1 bond with the carbon here, it also has 3 lone pairs to fulfill its octet, and as a result, it's going to have 4 electron groups, meaning we're also going to see sp3 hybridization going on here. And finally, the last heteroatom I'd like to discuss is this oxygen that's part of the alcohol functional group up here. So this oxygen has 2 bonds, one with the carbon here and one with the hydrogen here. As a result, it also has 2 lone pairs to fulfill its octet. And we can see again that we have 4 electron groups. So as a result, we're going to have sp3 hybridization here. I'm going to put that up here. Now I want to delve into this atom a little bit more as well. So as we said before, this atom has 4 electron groups, and so giving us sp3 hybridization. That would also give us an electron arrangement of tetrahedral. However, the molecular geometry is different because we only have 2 attached atoms. So when we have 4 electron groups and 2 attached atoms, we actually have a bent molecular geometry. So I'm going to write that here. And given that it's bent, our bond angle should be about 105 degrees. So when we look at this molecule overall and discussing its polarity, we see that yes, we do have a couple polar functional groups, the carbon to oxygens here and some of the ketones here and the alcohols. However, we have 22 carbon atoms. We have a lot of carbon-to-carbon bonding going on here, and as a result, that's going to negate some of the polarity. So I would say overall that this molecule is non-polar. We'll write that up here. And as a result of it being non-polar, it's most likely not going to be very soluble in water, if at all. Because if you remember, water is soluble, and when we discuss solubility, like dissolves like. So if this is non-polar and water is polar, then dexamethasone won't be very soluble in water. And this is supported by the fact that the stated water solubility in my research was anywhere between 1.98 times 10 to the negative 4th molarity to 2.28 times 10 to the negative 4th molarity. So we have a little bit of variation there. The temperatures for the experiment to determine the molarity might have been a little different. We were in the range of 20 to 25 degrees Celsius. I know the one that was stated at 2.28 times 10 to the negative 4th molarity was at 25 degrees Celsius. However, the one, the stated figure of 1.98 times 10 to the minus 4 molarity that came from the EPA was at a little bit of a lower temperature than the 25 degrees Celsius. So that might cause a little bit of variety there and a little bit of a difference. So that was my second molecular diary entry on dexamethasone. Thank you for watching and have a great day.